Okay, good afternoon to all of you. If the screen is also visible to you, then let us get started. Okay, so were you able to complete the other project? Okay, good. Okay, great if you've done it. Good. Okay, so today we are going to be talking about another project, which is something that is you are going to take up, and it is a good project in order to be added into your resume. And although it is kind of small, so can be added under the mini project section, but it is a great practice and will really help you understand a lot of concepts. So we are first going to begin talking about recursive functions first, and we are going to see basically what happens in recursion and how is it that you can use recursion. And so recursion actually looks a bit something which is kind of difficult and complex, but once you understand how it is done, then it will be great, because it is then very helpful. You do not really need to write a lot of things then, and your code size becomes small. Okay, so yes, let us begin talking about recursive functions. Let us also look into uh, some some of the examples, and then we are going to move ahead and discuss the project, because the project will be based on uh, recursion and you will have to implement the recursion in the project. Okay, so yes, so let us take up the most common example of recursive functions, which is finding out the factorial, right? So what is basically recursion? Can anyone of you answer that? What is recursion? What do recursive functions do? Okay, Palak is saying that in Python with OpenCV there are many tutorials, but there is no tutorial to do in C++ and OpenCV. I want to learn image processing and want to do project on my own. But there is direct code given on the net, not the things and nothing about functions. Okay, so yes, as Prashant has answered your question, you can obviously check the OpenCV's official website. In that particular website, they are only giving you information about what each function does and what are the different arguments that each function is going to take. They have also categorized the functions into different categories, and yes, so that will be helpful in that case. Okay, so yes, we were talking about recursive function, and I had asked what are recursive functions. So some of you have given the answers. So you are saying that a function which calls itself, recursion is based on divide and conquer approach. Okay. When function calls itself again and again, function that calls itself considering the base case, correct. Function veiling itself until base condition reached. Yes, so you are correct about it. let us move ahead and understand this. So basically the functions, we say these functions that call themselves with changed values. Okay, values, or you may call them parameters. Right, so we are saying that we have defined a particular function, and that particular function is going to call itself based on different values. So the arguments that you're going to pass to that particular function, when you're again calling itself from within its body, you can change the parameters, right? And there is another thing, which is that each recursive function is going to have a base case. So you say each recursive Okay, so let us look at one of the most common examples of recursion, which is to find out the factorial. So let us say you have this function here. Let me write down the function definition. So you say if n is equal to 0, then return 1. And otherwise, what do? You return n into factorial of n minus 1. Right? So this is a recursive function. This factorial function is a recursive function. We call this a recursive function because it is calling itself, and with changed parameters. You also have a base condition here, which is if the value of this variable n, which is passed as an argument, if it is 0, then you should return 1, and at this point of time your function is going to terminate, right? So how does it happen? So you say, let us say that I am going to call from the main function. I am going to call this given method factorial with the value, let us say 4. Okay, so if I say that okay, I am going to call fact of 4, so it is going to first check this condition. If n, which is 4, is equal to 0, if it is not true, then it is going to call fact of n minus 1, which is 4 minus 1, so 3, and here you can say 4 into this. Okay, now once it calls fact of 3, again it is going to check this condition. This condition does not become true, so you call fact 3 into fact of 2. Okay, then you again go ahead, call 2 into fact of 1, and then you call 1 into fact of 0, and as soon as you call fact of 0, and the value of n here becomes 0, and it is going to return 1. So at this particular position, when this function call is made where fact of 0 is called, a return value is sent here, and this value is 1. So this gets replaced by the value 1, and then when you multiply these two numbers, which is 1 multiplied by 1, you return that to the calling function again. So once you return this to the calling function, at this particular place you will have the value 1. Okay, and now you do 2 into 1, which returns 2, so you again return that to the calling function. So now here you do 3 into 2, right? Again you return this to the calling function, you return 6 here, right? And then here you do 4 into 6 and again return it to the calling function. Here you have 24, right? So once you have 24 here, again this function call is complete, and this is returned to the calling function. So the calling function here is the main function. In the main function, this value 24 is returned. Okay. So this is a simple recursive function. Now here if you see that we have the base case which is n is equal to 0. As soon as we have n is equal to 0, we know that we are going to return, let us say, a constant value with which there will be no more recursive calls. Okay, so as soon as this base condition is satisfied, there will be no more recursive calls and you can simply return. Okay, and another thing, if you let us say notice here, is that once you return this, so whenever you write this particular statement wherein you are recursively calling the function itself, the only thing that you need to do is just mention what I want to do. So you simply say that I am going to do it with for the nth value. So do uh, do for, let us say, for nth value, and rest of it will be done itself, right? So for the nth value, you say I should return n into fact of n minus 1. You only want to mention, so this is what is the thing here in recursive function, is that you want to do it, you are going to do it for the nth value. It is like you are telling the function that this is how you do it for the value n, and the rest of it is going to itself do for you, right? Right, so is this part clear to you? Obviously you know about recursion, but we are just reviewing this part here, how this thing happens, and just for your information to understand that we require a base case with which we are going to reach the end of this recursive calls, and we are no more going to make any more recursive calls and simply end the function with a return value. And another thing here is that you always want to do it only for nth value, and the rest of it will be performed by the function. So you just tell it for the nth value and it is going to perform the rest of it on its own. So up till here, is this part clear? Okay. So, okay, so it is okay. So you're saying that why is it coming back? So every time, so you see here, if for any particular function, let us consider an example wherein you have the main function. Oh, sorry. Okay, let me write it here. So if you say from the main function, you are going to call another function. Let us say you call int f is equal to fact of 4, like this, from the main function. Then whatever is the return value of this factorial function, it is going to be uh, first called. So this factorial function is going to be first called, and then whatever return value it is returning, it is going to come over here and be stored inside f, right? So the same thing happens here as well. Any calling function, so whatever function that you have called, it is going to return back its control, right? So that is why you go back with the return values. These are simply return values that you're going to give back to the calling function. Okay. So let us also, so since we have begun talking about recursion, let us also look into mutually recursive functions, just for you to understand what these are, and then we are going to move ahead. Okay. So we have mutually recursive functions. So what are mutually recursive functions? So by mutually recursive functions, we mean that whenever two or more functions are going to call each other in a recursive fashion. Okay. So let us look at an example, and then we will understand what are mutually recursive functions. So say for example that you have, let us say you have a function f1. Let us have two different functions f1 and f2. So let us have f1 with a variable as a parameter, which is, let us say, x, and let us also have a base condition. So the base condition here is, if x is less than equal to 0, then we simply return 0. Okay. And otherwise, what am I going to do? Otherwise I return f2, let us say x minus 1 into 2. Okay. So this is the first function that I have, first method, and the other method that I have is named as f2. It is also going to, let us say, have a parameter which is int a, and I am going to define the base condition. So the base condition that I'm going to sorry. So the base condition that I'm going to define here is, let us say, a is less than equal to 0, then you return 1. And otherwise you call, so you say return f1, let us say a by 2 plus 100. Okay, these are the two different functions. Now if you see here, what are they doing? So in the definition of f1, you have this particular value, which is the, this particular condition, which is the base condition here. So whenever the value of x is less than equal to 0, you simply return 0. And otherwise what do? You call this function f2, and in this function you have again a base condition, and this function otherwise is going to return with this function f1 with some certain arguments, right? So they are basically calling each other, and if you see, they are going to call each other recursively. So let us say, if from the main function you call, let us say, f2 of 5. Okay, so I have made a call f2 of 5. So what will be the return value? What will happen here? Can you try this and tell me the result? We have these two functions. I'm from the main function, I'm going to call f2 of 5, and I want to see how these, in which fashion these functions are going to be called. Okay, so yes, go ahead and solve this and then tell me how do you move ahead. Okay, so let me move along, and with this you should also move ahead. So if let us say I'm going to call this particular function f2 from main, let us say I call this from main, which is f2 of 5, then what is going to happen? You're going to call f2 with the value 5. So the value of a is 5. You do 5 if, check this condition, if 5 less than equal to 0, the condition is not true. So you make this call. Okay. So when you make this call, you are going to call f1 5 divided by 2, and since this is going to be in the integer form, so you see this is an integer, so this is going to result to 2. 5 divided by 2 is going to result to 2, and you are going to add a value which is 100 to this. Okay, so this is the first function, that is first function call that is made after you call f2. Okay, so what is the next thing that you do here? The next thing that you do here is you call this function f1, and f1 with the value of 2. So x is 2. Check this condition. If 2 is less than equal to 0, condition false. So you go here and call f2 again. So you see these functions f1 and f2 are called in recursive fashion, but this time you call it with x minus 1 value, which is 2 minus 1. So 1 multiplied by 2. Once you call this f2 again with the value 1 as the argument, check this condition. Condition comes out to be false. So what do you do? When the condition comes out to be false, you simply return this. So make another function call which is f1, and this time you do 1 divided by 2, which results to 0. Okay, so you call this f1 with 0 plus 100. Right now, once you've done this, you call f1 with 0 plus 100. You call this function with the value of x as 0. This condition this time becomes true. So this, at this particular position, 0 is returned. So you have 0 plus 100, which is 100, which is returned to the calling function, which was f2. So 100 is returned here. You have 100 into 2, which is 200. 200 is returned to the calling function. Calling function here means f1 had called f2. So the value is going to be returned back as well. So here you return 200. So you have 200 plus 100, which is returned back to the calling function. Here the value is 300. This value 300 is then returned to the main function, right? So the final value which is going to be returned to the main function is going to be 300. Now if you see, we have understood how mutually recursive functions work. So they are going to call each other in a recursive fashion. That is, let us say if this function calls f2, f2 is again going to call f1, and it is going to keep on doing that until the base condition of one of these functions is satisfied, right? So this is about mutually recursive functions. We looked into recursive functions as well, and we have also understood what are mutually recursive functions. So if any one of you have doubts, then you can go ahead and post them in the group. Otherwise, let me know if we shall move ahead. Okay, then we are going to move ahead and discuss the project. Okay, which part of this Here, do you want me to explain again? Is it mutually recursive function or is it recursive function as well? Okay, so let us look at this example of mutually recursive function again. So we say that mutually recursive functions are when two or more functions call each other in a recursive way. Okay, so we have these two functions and we have the main function. We have the definition of the two functions, but from main we are just calling a single function, let us say, for example, with a given argument value. So with this, when you call the function f2 with the value 5, you see from main you are calling f2 with the value 5, right? Once you've done that, you go here and you execute the statements inside this particular function. So you check this condition, a here is 5, so 5 less than equal to 0, condition becomes false, then you return f1. So you basically, in the return part of this particular function, you are going to call another function which is f1 of the value a divided by 2. So the value of a here was 5, so 5 divided by 2 is going to give you 2. So you call f1 of 2 plus 100. Okay, so once you call this function, again you execute the function with the given argument value, which in this case is 2. So x is 2. Again check this condition. This here becomes false. So you call this function f2 again. So when you call this function f2 again, you call it with the value x minus 1. X was here 2. 2 minus 1 gives you 1. So you call this function with f2 of 1 multiplied by 2, which has been given here. Okay, as you move ahead again, now this time the value of this argument a has now become 1. So what do? You check this condition, it becomes false, so you return f1 a by 2. A by 2 here is 1 by 2, so 1 by 2, since it is in the integer format, it is going to result into 0. So you have f1 of 0 plus 100. Now when you call f1 with the argument value 0, you actually uh, get 0 because this if condition here becomes true. So this is the base condition. This base condition becomes true, so it returns 0. So in this place you get 0, you have 0 plus 100 then. 0 plus 100 is returned to the calling function, which is 100. So you place 100 in place of the calling function. Now you have 100 into 2, which results to 200. It is returned to the calling function again. So once it is done, you have 200 plus 100 and this results to 300. Again return it to the calling function and so on. So the final value that has been returned to you is 300. The basic concept of understanding this is to understand how recursive functions work. So you had simply given the value of what is going to happen if I have a value n, let us say, or x in this case, and how should it return, and the rest of it is done by the function itself. Okay. Okay, so let us move ahead and let us now discuss the project. So the project that we are going to be having for the final project for this bootcamp is going to be a Sudoku solver. So does any one of you does not know how a Sudoku is solved? Everyone knows how it is done. Is there anyone who doesn't know how Sudoku is solved? Okay, so just let me know how. Do you know how Sudoku is solved or not? Okay, so you don't know how you don't know how Sudoku is solved? Well, okay. Okay, a lot of you know it as well. Okay, so let us do one thing. Just give me a moment because I thought that all of you might already know how it is done. Okay, so it is going to be a simple Sudoku that we are going to consider here, which is a 9 cross 9 grid, and it is going to have simple numbers, and you can simply solve it. Okay, like the ones that you get on in the newspapers as well. Yes, so you are going to be using recursion in order to solve a Sudoku. Okay. Okay, so let me first give you an example and then we are going to move ahead. Just give me a moment, everyone. Okay, so is this visible to everyone? I have pasted an image here, and in this image you have a Sudoku as well as its solution. Okay, okay. So for all those who do not know what a Sudoku is and how it is resolved, let us just move ahead and look at it. So the first thing here is that you will be so in the we are going to talk about this in terms of the project as well. So we say that you will be given let us say 9 cross 9 grid. Okay. So in us we are considering a 9 cross 9 Sudoku, and we are going to understand how will the input be given to you and what is the output that is expected. So we say that you will be given, let us say, a grid of 9 cross 9 numbers as an input. So it is basically in the representation of a two-dimensional array. Okay. So you will be given a matrix of 9 cross 9 size as the input, and it is going to be partially filled. So like this Sudoku here you can see is partially filled. In a similar way, you are going to have the Sudoku which will be given to you in the partially filled form. Okay, so let us along, as we discuss along, let us also write down the things so that you can note down the project as well. So you say that in input, what will be given to you? We say partially filled 9 cross 9 2D array. Okay, so this is the input that you get. Now, so what happens in a Sudoku basically is that, so for, it is recommended for all those of you who do not know how to solve a Sudoku, that you go ahead and solve, let us say, a Sudoku by yourself, and then it will be more clear to you about what we are going to be doing. But we are going to be anyway understanding each and everything here, but if you say you want to do it on your own whenever you are implementing the project, then you can do that. And not only this, so it is quite a fun, you know, fun task whenever you want to take this up. Okay, so we say that in a Sudoku, we have to, so we have a partially filled Sudoku here. In a Sudoku, what do we want to do? We basically want to fill in the empty cells. So the empty cells that we have here, we want to fill these cells such that in each uh, sub matrix or subgrid, which is of 3 cross 3 size. So you can see here this bold line is representing the sub matrix that you are going to have in each grid. So completely you are going to have 9 cells in each row and 9 cells in each column, right? So that is why you have a 9 cross 9 2D array. And now what you want to do here is that you want to fill these cells and give the output. So there is a way in which you are going to fill these cells. You cannot fill any number in any cell. So the first thing here is that the only digits which are allowed are from 1 to 9. Okay, only digits that are allowed are from 1 to 9, and there are conditions. So the condition is that no number, no digit should be repeated in a row, in a column, as well as in the submatrix. Okay, so you cannot actually repeat a number, or the occurrence of a digit should not be repeated in a single row in that particular column as well as in that subgrid or submatrix. So you see your 9 cross 9 grid is divided into submatrices or subgrids, which are of size 3 cross 3. So this is the first one, second, third, fourth, fifth, sixth, seventh, eighth, and ninth, right? Now in each of these grids as well, you cannot have a repetition of any digit, and the digits that are allowed are only from 1 to 9, right? So up till now, have you understood what is supposed to be done? Okay, especially those who did not know how to solve a Sudoku. Are you understanding what is it that we want to achieve? Then we are going to move ahead and see how you can solve this as well. Shall we move ahead, everyone? Okay. Yes. So now look at this example here. So let us try to fill in a number, and then you all those who do not know how to solve it, you're going to understand how is it that you can solve it. Okay, so let us consider a single grid. So let us consider I want to fill in numbers in a particular subgrid. Let us consider this one here. And now in this subgrid, I see that only three digits are missing here from this first subgrid or submatrix of size 3 cross 3. Three digits are missing. You see that you do not have, what are the numbers that you do not have here? So you do not have 1 in this here. You do not have 2. You have 3, 4, 5, 6, 7, 8, and you do not have 9. So these are the three numbers, and these are the three empty cells, but you will have to know, you will have to find out the correct position of a particular uh, digit and its correct cell. Okay, so what do you do here? You say that okay, I'm going to try on with the first element. So let us say you want to place 1 here. So can you place 1 here? No, you cannot. So you, what do? You try. You first, before placing. So this is whatever I'm going to explain you right now is also going to be the approach of solving this Sudoku and how you are going to implement it. So listen to it very carefully. Like we normally solve a Sudoku, in a similar way, we want to solve this particular problem using recursion. Okay. So you say that, okay, I want to write down the number 1 here, but can I write it? I cannot write it. Why cannot I write it? Because in this particular row where I want to, so this is going to be, let us say, the 0th row and the 0th column. Okay, so now in the 0th row and the 0th column, what is the condition for a number to be placed at a particular position? So first you find out an empty cell. Once you have found out the empty cell, you keep a track of its row number and column number. And next, what do? You first check if this, so you, let us say you want to fill 1 here, and you check if it is safe to fill 1 here or not. So checking safe will involve you to check if in this same row I have the element that I want to fill here or not. If I already have 1 in this row or in this column or even in this sub matrix, then I cannot fill 1 here. Okay, so that is the condition that you will have to check before filling in any element at a empty cell. Okay, so I check if I can write down 1 here. I cannot, because in this same row I already have 1. Okay, so I cannot fill in 1 here. Okay, so now what I want to do here is I want to try, let us say I am going to now try 1 here. I try if I can fill 1 here or not. Again, I cannot fill 1 here because at this particular row, again I already have 1. So this means that 1 cannot be filled in this row anywhere. 1 cannot come here, it cannot come here, here or here. Okay, so the only position that I have left for this subgrid or this submatrix for the element 1 is this. So I fill 1 here. Okay, is this clear? How did I fill 1 here? Is this clear to everyone? Now let us say that I want to, so the condition here in order to fill the Sudoku is this only, that each row is going to have numbers from 1 to 9, each column is again going to have numbers from 1 to 9, and each submatrix will also have numbers from 1 to 9. Okay, so if I have, let us say, 1 in this column, so the way I am doing it is how you generally do it whenever you want to fill a Sudoku. This is how you move ahead. So I have just now filled 1 here. I know that 1 is in this column, which is column number 2. 1 is in this column, which is column number 1. It is here. And in column number 2, it is here. But in this column, which is column number 0, I do not have a value 1. So let me try to fill 1 in this column. So how will I do that? I'm going to see where all can I not have 1. So I cannot have 1 here. When I consider this column, I cannot have 1 here because I already have 1 in this row and I also have 1 in this submatrix. So in this submatrix, I cannot have another 1. In this submatrix again, I have 1 already. So I cannot fill 1 here or here. But in this submatrix, I do not have a value 1. And in this submatrix, I cannot fill 1 here because this column already has 1. In this column, in this particular submatrix, in this column, again, these two empty cells cannot be filled with 1 because this column already has 1. But this column can have a value 1. Again, when I consider these two empty cells from this particular submatrix, I cannot have 1 here. Why can I not have 1 here? Because I already have 1 in this row. So the only position that I have left for 1 in this particular submatrix is this. Okay. Now let us fill another value. So let us say that I have 1 in this submatrix, I have 1 in this submatrix, but I do not have 1 in this submatrix. So I cannot fill 1 here, right? I cannot fill 1 here because it is already in this row. I cannot fill 1 here because it is already in this row. The only place I have left for this 1 is here. I cannot have another 1 in this submatrix. I cannot have another 1 in this submatrix. Only position I was left for 1 with this place. Okay. So has everyone understood how are you going to let us say make out and okay. So this is how you generally solve a Sudoku. This is the one thing that you do. Let us, if up till now everyone has understood, let us move ahead and understand what is it that is going to be given to you in the project in the form of the input, how you are going to represent it in the form of the output, and what is the approach that you're going to follow. Okay, so looks like a lot of you have understood. Let us move ahead then. So as we looked here, we said the input that will be given to you is going to be a partially filled 9 cross 9 2D array. And by partially filled, I say that I'm going to have a 2D array, which is 9 into 9, which is 81 elements are going to be given to you in the form of the input of a 2D array. So like you simply take input of a 2D array, you can do that. For all the places where the value, the cells are empty, you can consider that as any value of your choice, which is not among the digits 1 and 9. Okay, so you can either consider it 0 or you can consider it as a negative number. Okay, so is the input clear? Let us look at what is the output that is expected from you. So the output is simply the sorted Sudoku or the solved Sudoku. So you say, okay, so simply you are going to give out a matrix which is going to be of 9 cross 9 size, and it is going to be of the solved form of Sudoku. Okay, now there can be different cases, edge cases that you can consider. So let us look at them as well, and then we are going to move ahead. So those edge cases are, let us say, going to include what if. So it is possible that if you are taking, let us say, input from the user, it is possible that the user gives you the completely filled Sudoku. Okay, it is possible in that form as well. So let us consider the edge cases. We are going to look into some certain edge cases that we can think of right now. If there are any other edge cases, you should be able to think about those and, you know, try to implement what should happen in that case. So the first case here can be that input is a invalid Sudoku. Okay, so for all of those who do not know about Sudoku much, it is possible that the Sudoku is not valid. Not all Sudokus have a solution. So in that case, we are going to consider that as an edge case. And if, say, suppose the Sudoku is invalid, then you should be printing a proper message. Error message, let us say. Okay, so if the input is not valid, you should print a proper message for the user to inform that the input Sudoku is not valid and it cannot be solved. Okay, so this is, let us say, one of the edge cases. The other thing that you can have is, let us say, if Sudoku is completely filled, let us say, for example, or let us say it is completely solved. Now it might be possible that the user gives you a completely filled Sudoku as an input. So what are you going to do in that case? You can simply output. So there are two different things that you could do. So if, let us say, the user gives you the input of a Sudoku which is solved and it is solved correctly, completely solved and solved correctly, then you can simply say that it is already solved. And it is possible that the user gives you the input of a completely solved Sudoku, which is, let us say, not correct, wherein, let us say, for example, this value 5 here is occurring 2 times in the same row. It is possible in that way as well. So this is something that you're going to again consider as an edge case, and whatever you wish to do, if you simply wish to print a message, then do that. Otherwise, whatever you want to terminate the program, do that, and so on. Okay. Then print message for user again. Okay, so this is about some certain edge cases that you can consider. Now, obviously, before beginning, every time you will have to check with these edge cases, right? If the Sudoku is completely solved, then you can simply say that it is solved, or give out the same output as the input has been given to you. And if it is, let us say, not valid, then simply print the message and move ahead. Otherwise, if it is valid, so if this invalid check is, let us say, passed and the Sudoku is not invalid, then what you should do? So now you should move ahead and solve the problem. Okay, so solving the problem basically means that solving the Sudoku. So how do you do it? So let us look at the approach now. Okay, so now whatever you want to do with these edge cases is totally up to you. So this part of the code is left to you about how you want to handle these conditions. It can be different for a person, for a single person, let us say, and can be different for another person as well. Okay, so it is completely up to you if you want to print a message, or if you want to terminate a program, or if anything else that you can think of you want to do that, then go ahead and do it. Okay, so let us discuss the approach. So the approach here is the first thing, which is let us say, okay, so the first thing that you do is you check if the Sudoku is valid or not, right? Now, if it is valid, you go ahead and find out a position which is, let us say, not filled, or it is empty. So find out a cell which is empty. Okay, so this is the first thing that you need to do, is that you obviously you want to fill a number at a position wherein you have an empty cell, and you do not want to touch the other cells which are already filled, right? So you first find out a cell which is empty, and obviously now you see, once you find out a cell, so say for example, I find out this cell which is empty, the first cell. So what is the requirement here? I will keep a track of which row and which column number this is, right? Why? Because I want to go ahead and check if this, if at this cell, whenever I want to put in a number, I will also check the same row and the same column before I fill in any element here. So you keep a track, check if the cell is empty, and keep a track of column number and row number, right? Okay. Now how do you move ahead? So the approach that we are going to discuss is going to be the recursive approach. So we say the next thing that you do is you simply assign a number to the empty cell. So you are, so before, okay, so what do you do here? So like we moved ahead, what did we do? We first, let us say I wanted to put in the number 1 here. I want to assign the number 1 here, but before assigning, what did I say? I say that before assigning, I am going to first check the row, the same row, the same column and the same submatrix if it contains the same the element that I want to fill in here or not. If it contains the same element, then you cannot fill the same element here. So you move to the next number and you again check if it is safe for you to fill in that number here or not. Okay, so you say that uh, consider a number to be filled in the empty cell check. So cell first check if it is safe. If yes, then assign. If yes, then assign the number to empty cell. Otherwise, try a different number. Different number or digit. Okay, so this is what you want to do here. So what did we do here for this particular case? You, let us say you picked up 1 and you wanted to assign 1 here, but before assigning you checked if it was safe or not. So to check if it was safe, you first simply traversed the row, same row, and traversed the column and checked if it is possible for you to uh, fill in 1 here or not. So this was not possible. So what did you do? You moved to the next element. You said, okay, 1 is not possible. I am going to try filling in 2 here. So you tried filling in 2 here. How did you try that? You said, okay, let me check if 2 is in the same row or not. 2 is not in the same row. 2 is not in the same column and 2 was not in the same submatrix as well. So you wrote down 2 here. Okay. So similarly, you should go ahead and do that for all the cells. Okay. So is up till this part is everything clear? Is up till here everything clear to you? How you should move ahead with this? So pick up a number, you want to assign that number, but before that you check if it is safe to fill that number in that particular empty location or not. If it is safe, then you simply assign it. If it is not, then you move and check with the next digit. And how do you check? So let us say you begin with the digit 1. You begin with digit 1, then you check if it is not possible for you to print or assign 1 there, then you check with 2. If it is again not possible to assign 2 there, then you check with 3 and so on. You do it till 9. Okay. Okay, so there are certain questions in the group. Should we search for empty cells row wise or column wise, or is the order irrelevant? So basically that really doesn't matter because you are doing it recursively, and once you keep on doing it recursively, you're going to see if this particular order is fine or not. Now we are going to come on to the next concept as well. We are doing it with recursion, but there is this concept of backtracking, which I'm going to explain you, which is nothing different. It is only recursion, but the thing is that you're going to understand it just when I explain it. So yes, so there are hard sudokus also in which we can't get the digit by only looking in the rows, columns and the submatrix. Then in that case, how will we have to work? So you do not really have to understand what, okay, so there is a difference here. So there is a difference in actually being sure of which number you want to fill in at a particular position. Okay, so please focus here. This thing is important. We say that whenever you are actually solving Sudoku on pen and paper, so when you do it on the pen using pen and paper, what do? You write down the digit only if you are very sure. Very sure means only if you know that this is actually the correct place for this particular digit. But using recursion, the approach that we are following, in this approach you are not going to be sure if this is the digit which is going to come in this particular position. You are only going to fill in the digit at a particular position if those three conditions satisfy. And what are those three conditions? Those three conditions are, first, that this element that you want to fill in is not in the same row. Second, this element is not in the same column. And third, this element is not in the submatrix. If only these three conditions are true, then you simply fill in that particular number at the same position. Okay. Okay. So here, as pointed out by Mayank here, you see that when you pick up this particular cell, okay, so this is how your program should work. Please focus here and listen to this part carefully. If let us say this is the empty cell that your program picks up, you pick up this empty cell. Now you start from digit 1 and go on up till digit 9. So when you start with digit 1, you check if I can place 1 here or not. So you found out this 1 here, so you say that I cannot place 1 here. Okay, then you try with digit 2. So you try with digit 2. Digit 2, you cannot find 2 in this row, you cannot find 2 in this column, and you cannot find 2 in this submatrix. So you simply write down 2 here. You write down 2 here, then you go to the next empty cell and you do the same thing. Okay, and again you do the same. Once you've done the same thing, you go keep on doing that for all the cells, and you keep on finding it, if keep on checking if this condition is coming out to be true for you or not. Okay, then if it is not possible, you remove a certain element and then go ahead and try. Okay, so what is the next step? As we have just now discussed, the next step here is going to be similarly like this particular step here, the second step, in which you consider a number to be filled in the empty cell. First check if it is safe. If yes, then assign the number to empty cell, otherwise try on a different digit. Okay, so once you've done this, you similarly try to fill other empty cells, and so this part, the third step here, is done recursively. So you recursively keep on trying for the different cells. So you say that do this recursively. Okay, and now you say if you are able to fill all the cells without any conflict. So if you are able to fill all the cells without any conflict, then simply return the solved Sudoku. Okay, and if you are not, okay, okay, so what do? Up till here, you keep on trying. So like here you begin, you say, okay, I can fill 2 here. Then you go ahead and again try for digits starting from 1 here. Okay, so for this place you try with 1, you cannot fill 1 here. You try with 2, you cannot fill 2 here. Why? Because 2 is already in the same row. Then you try with 3, 3 cannot be filled here because 3 is in the same row as well as in the same column. Then you try with 4, 4 cannot be filled here because it is at this same row. Then you try with 5, 5 is in the same row, 6 is in the same row, 7. Now you try with 7, 7 is not in the same row but 7 is in the same column. Then you try with 8, 8 is not in the same row, 8 is not in the same column but 8 is within the same submatrix. Then you try with 9. So 9 is not in the same row, not in the same column and not in the same submatrix. So you fill 9 here. Then up till now this part is empty. So again you either go here, and if you want to do it, let us say row wise, you're going to try for here. Here when you try, you check if 1 can come here. 1 cannot come here because it is in the same row and same column as well. 2 is in the same row, 3 in the same row, 4 in the same row, 5 in the same row, 6 in the same row, 7. Let us see for 7. 7 is not in the same row. Is it in the same column? No, it is not in the same column. Is it in the same submatrix? No, it is not in the same submatrix. So you fill 7. You move ahead. Try with the different, try again on the different cell, starting from 1 going on up till 9. So if you start from 1 go on up till 9, there will be at least one element that you can fill in this particular cell. Now say for example, you filled the wrong data in the cell. You filled the wrong data in the cell, then it is possible that at that particular time you will be able to move ahead, but at a different place you will be stuck. And when you will be stuck, you will by then understand that this is not the right solution for the Sudoku. So in that case, what do? You go back and you erase or remove that element that you had just written and try with the different digit at that particular position. Okay, so that is what recursion will do for you and backtracking will do for you. The only thing that you will need to do here is for okay, so I have already answered the question that Mayank had asked. Okay, did you guys not listen when I was answering this question? Shall I go over this again? Why should you be why will your program fill 2 here when you can also fill 9? The program is not going to work like you do yourself. So like you do solve, as I said, you solve on the paper, the program will not consider absolute surety of a particular element. It is just going to check the 3 conditions. If those 3 conditions are true, it is simply going to place that particular element at the position. Okay. So again, let me go over this. Let me just remove everything that I have written down. So again, please listen carefully. I am going to answer this particular question again, which is we can store. So here the question as well. Mayank says that we can store 2 and 9 both in the first place. So which number will be stored by the program? So with the approach that I have told you, as we move ahead, what are you going to do here? You first try, so you actually begin with numbers. So you say I have an empty position, and you say that I can fill all numbers from 1 to 9 here, given that I have a certain condition that is satisfied. And what is that condition? That condition is if the same element is not in the same row, if the same element is not in the same column, and if the same element is not in the same submatrix. Okay, so you begin, let us say, if you begin with a loop from 1 to 9, you go on from 1 to 9, you begin with the first digit, which is 1. So you, before filling in 1 here, you check the condition if 1 is in the same row. So you find out, yes, 1 is in the same row, you cannot fill 1 here. So in the next iteration of the loop, the next element that you pick up is going to be 2. Then you try for 2 here. Okay. So once you try for 2 here, you say that 2 is not in the same row. 2 is not in the same column. 2 is not in the same submatrix. All these three conditions are satisfied, so you simply place 2 here. This is what the program will do. It will just check the three conditions, and if it is you know, satisfying for any particular value of this element, it is going to simply place this value and stop right there. So this loop, once you fill 2 here, it will stop right here and it will move to the next empty position. Now the next empty position, if let us say your program picks up this next empty position, it again starts the loop from 1. Once it starts the loop from 1, it again checks, can I fill 1 here? Your program is basically dumb. Why? Even though you have, so let us move ahead with this and then let us understand. It says that, okay, I'm going to check for 1 here. Can I fill 1 here? No, I cannot, because it is in the same row. So you simply move to the next iteration. You check for 2. Now it is you as a human being who knows that I have already filled 2 in the same submatrix. Why should I even check for 2? But no, your program is going to do it, right? Your program is going to check for 2 also. So it is going to check for 2. Can I fill 2 at this particular position? No. Why? Because it is already in the same row. So you do not fill 2. Then you check for 3. You check, can I fill 3 here? No, I cannot, because 3 is in the same row. Then you check for 4. Can I fill 4? No, 4 is in the same row. Can I fill 5 here? You already know 5 is already in the same submatrix, but no, the program is going to check each and every digit starting from 1 to 9. And as soon as it finds a digit which is satisfying all the three conditions, it is going to place that digit at the position and simply move ahead to the uh, next empty cell. And it keeps on doing that for all the cells until it has either found out that this is the wrong assignment, or it it basically solves or assigns to all the empty cells, and you have found out the solution. Okay, so once you check for 5, you cannot fill 5 here. You check for 6, then the program checks for 6, then 6 cannot come here because it is in the same row. 7, check for 7. 7 is in the same column. 7 cannot come here. Check for 8. 8 is in the same submatrix. It cannot come here. 9. 9 is not in the same row. It is not in the same column. It is not in the same submatrix. So these three conditions are satisfied. It is going to say, okay, let us place 9 here. Then if you pick up the next empty cell as this, let us say you pick up the next cell as this element here. This is next empty cell. You pick this up again, starting from 1, check if 1 to 9, check which element can you fit here. So 1 is already here in the same row. It cannot come at this position. 2 is already in the same column, cannot come here. 3 in the same row. 4 in the same row as well as in the same column. 5 in the same row. 6 in the same row. 7 Let us check if 7 can come here. 7 is not in the same row. 7 is not in the same column. Is 7 here in the same submatrix? No. Simply place 7 here. Move ahead with the next element. Okay. So your function or whatever program you create should recursively do this for all the empty elements, and do this until you have found out the solution, which is you have filled all the cells completely. Is this clear? Is the approach clear to everyone? Is there anyone who still has a doubt? Or if you haven't understood any part here, is there anyone? Okay, how are you going to keep a track of the element that you want to erase or change? Okay, so what will happen? Let me move ahead with this as well. So this is the correct time for this question. Now you know how it is going to work. It is going to, let us say, just start for a particular element. Now, how is it that your algorithm, whatever you are going to write recursively, is going to understand that I have reached a point uh, which is where my Sudoku is not correct, and I have made some mistake and some element has to be changed. That is, so that condition, when will that condition be true? So whenever, let us say, I pick up an empty cell. Let us say I have filled up some number of cells here, and I have reached a point. Let us suppose here. Let us suppose here you have reached, and now what do? You again, for this particular position, I'm currently considering only an example. Okay. So by the only example, I mean that let us assume that I have begun with checking for, I'm going to check which element should come here starting from 1 to 9. So if I start from 1, let us say, and I say that 1 should not be placed here. Okay, then I check for 2. 2 again should is not safe to be placed here. Okay, then I check for 3. 3 is not safe to be placed here. 4, 5, 6, 7 and 8 and 9. So when this condition comes, that is, for all the 9 digits starting from 1 to 9, when for none of the digits those three conditions are going to satisfy, it means that something has gone wrong. Something has gone wrong, right? And how will that happen? So say suppose by just considering those three conditions, I have filled in some numbers, my program has filled in just some numbers, and say one of those numbers is not at its correct position. That obviously while solving the Sudoku, so all those who have already solved the Sudoku would understand this, and all those who came across this thing will understand. For others, that is why I'm recommending that you should go ahead and first solve a Sudoku in the newspaper, or let us say anywhere online. So you might have come across this condition that as soon as you fill a wrong element at a particular position, आप कहीं पे आगे जाके अटक जाओगे. At some point of time when you're filling, let us say, some other box, you will find out that at this particular box I cannot fill in numbers, any number from 1 to 9. सबके लिए from all numbers, all digits from 1 to 9, it is going to be stuck because you will not be able to put in a particular number. अगर आपसे कभी सुडोकू में गलती हुई है, then this is what you might have encountered, that at a particular position आप कोई भी नंबर नहीं फिल इन कर पाओगे. क्यों? क्योंकि आप बोलोगे कि either this number is in the row or it is in the column or it is in the sub matrix. ठीक है. So the same condition will happen here when your program is going to realize, let us say realize, it won't realize, but anyway, it is going to come across this thing that I cannot fill in any digits from 1 to 9 at this particular position. So what it is going to do, in that case, it is going to go back to the position that it previously filled. तो मान लो इससे पहले इस पोजीशन पे आप आए थे, एंड एट दिस पोजीशन यू फाइंड आउट कि आई कैन नॉट फिल एनी डिजिट स्टार्टिंग फ्रॉम 1 to 9. सो व्हाट विल यू डू? यू विल गो बैक एट द लास्ट डिजिट यू फिल्ड. लेट अस सपोज इससे पहले यू फिल्ड दिस डिजिट, और यहाँ पे व्हाट विल यू डू? यू विल ट्राई विद अ डिफरेंट एलिमेंट. ओके, सो check if it is possible for you to write down any different element other than the element that you have written here, and then check for the rest of it. मान लो आपने यहाँ पे पहले 8 लिखा था, and now you say, let us just consider an example. It is not possible for you to write 8 here obviously, but let us just suppose for this example कि you have written down 8 here, let us say, and now you say that it is going to be wrong for me to fill 8 here. I cannot find any digits that should be placed here. So you go back, you check that can I fill any other number other than 8 here. If it is 9, let us suppose, you say that okay, for 9 as well, the condition is going to be satisfied. So I fill 9 here, and then again I move ahead and check. Again you go ahead and check at the next position if it is now working for you for you to fill the digit or not. ऐसे करके you keep on doing this. So अब से if possible यहाँ पे आपने सारे digits जो हैं वो try कर लिए, but इधर still you cannot fill a particular digit. So you will go back to one place जहाँ पे आपने इससे पहले भरा था. ठीक है. So यहाँ पे again you are going to check, can I work with some other digit here? Again, if it is not possible here, you go to the next, or not next, the previous digit that you filled, or the previous empty cell that you filled. वहाँ पे try with a different set and then go on. So this, now obviously this thing looks tedious and it looks very complex, but it is not whenever you are going to use recursion. That is why we studied about recursion, and this thing here, which is actually going back to the previous element and changing its let us say configuration, you are going to check, keep on checking if this is now something that you will be able to solve your Sudoku with. Okay, so this thing which is going back is known as backtracking. यहाँ पे क्या हो रहा है? Backtracking हो रही है. So आप क्या करते हो इसमें? It is sort of hit and trial, कि आपने बोला कि ओके 2 यहाँ पे इन कंडीशन के हिसाब से प्लेस कर सकते हैं, तो आपने कर दिया, और फिर आप आगे गए, लेकिन आगे जाके आपको पता चला कि नहीं, कुछ गलती हुई है, सो यू गो बैक एंड चेंज, एक पोजीशन चेंज किया, फिर चेक किया सही काम कर रहा है क्या, अगर कर रहा है तो ठीक है, मूव अहेड, अगर नहीं कर रहा है तो गो बैक अगेन, चेक विद अ डिफरेंट नंबर, अगेन वहां पे भी अगर किसी डिफरेंट नंबर से नहीं कर रहा, सो गो बैक अगेन एंड चेक विद अ डिफरेंट नंबर. So this approach of solving any particular problem is known as backtracking, जहाँ पे आप पहले you try with a certain set of numbers, अगर नहीं काम करता so you go back, change एक एक करके, एक एक पीछे जाके you are changing the values and checking if it is working for you or not. Okay, again I am saying this sounds very tedious and it looks like it is very complex for you to write down the code, but once you understand it is not, and you'll be able to do it very easily. It is just a few lines of code. Okay, so is this clear? Is this clear to everyone? Okay, so there is this question, how can we fill the empty spaces row wise if we have the submatrix, or we should fill it in the submatrix order. Now that is totally up to you how you want to do it. If you want to say move ahead in row wise, you can do that. You want to move ahead column wise, you can do that. You want to move ahead submatrix uh, times, you can do that as well. So that is, this thing has been left to you about how you want to um, approach here. Now this is how your codes are going to be different. Obviously I am not expecting that all of you are going to be writing down the same piece of code just because we are performing backtracking and recursion. Obviously it is not possible for all of you to write down the same piece of code. There are going to be changes. So yes, there is going to be a plagiarism check as well on your projects, and we are going to see how is it that, because there are a lot of things that we have left up to you. You can, let us say, pick up from numbers 1 to 9, or let us say from 9 to 1, or in whichever form that you want to do it, right? And then the next thing which we have kept up to you is that if you want to fill in the empty cells row wise or column wise or whatever way. Okay. Okay, so have you understood what is going to be the input and what is going to be the output? So the output that you're going to finally be giving is the solved Sudoku, which is a 9x9 matrix, which is the output that you're going to give, and it should be solved. And say, for example, if these edge cases are going to occur wherein your Sudoku is, let us say, completely filled, or if it is invalid, then it is your wish if you want to, let us say, print an error message, or if you want to terminate the program, whatever you wish to do, you can do those things. Okay, now shall we move ahead and talk about what are the things that you need to do apart from this in this particular project? So has everyone understood the approach? And so obviously you are not going to be able to do it in one go. You should keep on practicing it. If at any particular point of time you are, let us say, stuck at some point, then you can put in your queries in the group. Otherwise, you can ping me, or you can even ask your friends. So the discussion of this project is allowed among the friends, but this only the discussion is allowed. It does not mean that you're going to share the code. Everyone should be able to code themselves, and you should move ahead just by discussing, and just by, let us say, you can just tell wherever you are stuck, and then any one of your friends can provide you the solution of how you should move ahead. Okay, so shall we move ahead and look into what are the other things that you need to do with this project? Okay, so there is this other thing that so like I mentioned for the other project that you will have to create a readme file. Similarly, in this project as well, I am expecting that you create a readme file. So what are going to be the contents of the readme file? So the first thing that your readme file should have is what is it that you have used. So information about what the project is. So okay, so this is the format that I'm going to be discussing now is not only for this particular project, but it goes for all the projects that you're going to be creating. It is always the best practice that you create a readme file, and these are basically what contents you can have in your readme file. So information about what the project is, uh, what technologies you have used, how can a user run your project and use it. And so not only this, the next things that you are going to do in the readme file are going to be in the form of things like what are the different functions or let us say methods you have created. Okay, so this will basically involve the definition of all the functions that you have created in your project or whatever program that you're going to create. So say for example, let me give you an example of how you should do it. So say here you are going to first for this edge condition, sorry. So it should be in the form of a PDF. If you are creating a README file, it should be in the form of a PDF. The ex basically this really doesn't matter in which format it is, if it is in PDF or if it is a Word file, but since PDF looks basically clean, so it is preferred more. And so what is the meaning of technology here? We are not actually referring to this particular project. I am going to write, I am writing it here in the general form. So here technology basically means, so let us say that in this particular project, you might have, let us say, used different softwares. Even in the previous project wherein you used, let us say, VS Code, like I mentioned yesterday as well, you are going to mention that, and you are going to also write down what are, so in this part only you're going to also write down in which programming language you have implemented the project, along with what all platforms have you used, what all softwares you've used for actually solving this particular project. Yes, so as I was saying, so whenever say this for this particular edge case input, wherein you are going to check if the input is invalid or valid, you can create a function for this. Okay, so you will have to, let us say it is always, so since you already know, it is always a good practice in order to make your program modular. By modular I mean that you have a function or a method for each set of task that you have to perform. So let us say you can have one module or one function or a method for checking if the input Sudoku that you have is valid or not. Okay, so for that, if let us say you create a function of is Sudoku valid, you are going to, let us say, tell about this particular function, define this particular function, and just simply say that in this function. So what do? You say that this is the function, this is one of the functions that I have, and ahead of this, writing down this, what do you call this, the not the definition, the declaration. Yes, so the declaration of the project, once you've written that, the name of the function, what all arguments it has, you are going to explain that this function, so you go ahead by writing down saying that this function for me is going to check if the input Sudoku is valid or not. By invalid, now further you are going to mention that what are the different invalid cases. So you are going to mention one of the invalid cases can be that the Sudoku does not have a solution. Then there can be that there is a repetition, there is already a repetition of a single digit in a row or column or submatrix, whatever. And then there can be another condition for a Sudoku to be not valid is when, let us say, from the 9 cross 9 grid, you are not given the complete elements, you some elements are missing. So all these cases can be can come under Sudoku not valid, right? So this is basically how you're going to define the functions or the methods that you have created in the readme file. So this readme file is something that I'm expecting in both the projects that you're going to be creating. So yes, this is one of the things. Okay, is there any restriction of the programming language that you should be using? We are going to prefer that you code it only in C or C++. So you have a choice between C and C++, since this bootcamp was majorly, you know, uh, on these two programming languages. So this is what is preferred. Uh, that you code in either C or C++. Obviously, because some of you had requested, I had been giving Java as a choice in the test, but it is not one of the choices in case of this project. You can have only the project submission in C or C++. Okay. Okay, so apart from this, if there is any other question, then you can ask me right now in the Telegram group. Otherwise, I hope the project is clear to you. What you have to do is clear. What is the input, what is the output, and what is this README file that is expected from you. So these are all the things that the README file is going to contain. Okay. Okay, so again, the same question. Where and how do you have to submit it? We are going to give you all of those details. No worries about that. Uh, those details will be given to you, and your project submission is going to be considered. So no worries about that. Just focus on doing it first, because yes, that is the important part. Obviously, so it is not like if you're thinking that we won't be considering your submissions, or we just want you to create this and we won't be evaluating your submissions. We are going to make you submit these projects, but how and when is something that you will be informed of well in advance, so don't worry about that. Okay. Yes, any other questions, anyone, or any doubts? Okay, so if there are no doubts and no questions, then let us end the class for today. And thank you all for attending all the classes through the week if you have, and hope you have learned at least something out of these classes, and it is going to help you in your placements or anywhere um, in your life. At least you get to know something and you get to learn something. Hope I have been a part of your learning process. And yes, thank you all. And the rest of the details about the project submission will be informed to you. So do not need to worry about that. We had the last class for the bootcamp today. As mentioned earlier, the conditions for completing the bootcamp successfully is going to be the project submission. And if there is any other evaluation towards the end, we will let you know about it that as well in advance. And apart from that, the attendance as well as the tests were mandatory. So yes, that will be all. Okay, thank you everyone.